Welcome to July 5th LeetCode Challenge, Reshape the Matrix. In MATLAB, there's a handy function called Reshape which could reshape n by n matrix into a new one resulting in a different size called R by C, keeping its original data. You're given an n by n matrix MAT and two integers R and C representing the rows and column numbers of the wanted reshape matrix. Reshape the matrix should be filled in with all elements of the original matrix to the same row, traversing as they were before, as they were. If the reshape matrix operation gives a parameter that is possible and legal, the output should be a new reshape matrix. Otherwise, return the original matrix. So we're given the matrix mat here, where we have 1, 2, and 3, 4. We have R of row of 1 and column of 4. So we want to reshape this matrix into this one, which is possible because the number of rows and columns do match a reshapeable matrix. So we get the output of 1, 2, 3, 4 in this 1 row / 4 column type arrangement. In this example here, it's telling you you're given the original matrix here, 1, 2, 3, 4, and you're told to reshape the matrix into a 2 row and 4 column type of matrix. It's not possible to reshape a matrix that has a greater number of cells than you have originally, so therefore you return the original matrix. Here's some of your constraints here. So there are some hints telling you to how to think about how the two-dimensional matrix is stored in one-dimensional memory. It's telling you to apply this type of thinking behind it using the indices and the numbers, and to make this type of formula using division and modulus functions to help convert the one-dimensional matrix into a two-dimensional index. And then there's a formula here which will use something similar to that. Alright, so let's go about, this is a pretty simple, straightforward one. If you just kind of apply all these hints here and you think about it, it's, I'll walk through the code and we'll walk through the steps along the way. So the first thing we want to do is define the dimensions of our matrix that we have. So it'll be m and n, which will be assigned to the length of the mat. And then the other one's going to be length of mat at index 0. So now we have the length and width, the height and width of our matrix. Come here. Next thing we want to do is we want to find if we are able to make the matrix, if we have the possible number of cells in order to reshape the matrix. So we want to do R star C. So we want to know if the rows and columns of the numbers of cells are equivalent. So that's the only way that we can reshape the matrix, if the number of cells in the original matrix is equal to the number of cells in the reshaped matrix. Star n. If that's the case, return the matrix we have, return the original. So we know that if this is not the case, then it's an invalid size, therefore return the original matrix. So we want to have, let's call it an output. So our output is going to be a matrix, an array within an array. So let's do some list comprehension here just to make the array within the array so we can build it. So we have initializing our columns in the original array. So we're initialize that with columns of zeros, and then for each cell or blank in the range of the row, what we're going to do is so this is initializing the array of array, so this is going to be our output. So next thing we're going to do is we're going to populate our matrix. So in order to do that, let's do a for loop here. We're going to do a for loop for I in range of n by n. Just make it look nice there. So what you want to do is you want to update the cells of our output. So output. So what we're going to do is we need two cells here. So the first one is this hint here is telling you to use the division and modulus functions here, which we're going to do in this type of form. So what we want to do, so for each index of our that we're probing through in terms of a matrix, we want to take the floor division or the integer division of each column, and then we want to take the modulus of each column as well, of each index. That's what we're going to use. That we're going to reassign that with the following. So we want to reassign that with the matrix of the columns above it. Not above it, but so that's the columns row. So we want that, take the integer division with the number of rows in the original matrix, and then we want to reassign that to the column of the new output matrix. And then likewise, I take the modulus with n. So yeah, that's pretty much it. And let's run this and see if this works. Same, looks the same. Okay, accepted. So pretty much we're finding the row and columns of the original matrix. We want to know if the row and column that we're given of the reshape matrix has same number of cells as the matrix that we're given. If so, we continue. If not, return the original matrix because it's an invalid size. We initialize our output by making we did a list comprehension with creating a list inside it for each cell within the range of R, which is the row that we're given to reshape the matrix. So we initialize the matrix that we're given with the column as well. So we reshape the matrix. And then now we just need to populate each of these zeros, or each of the blank spaces in the cell of the reshape matrix with the original numbers in the original matrix. So we do a for loop here through m by n, and then we just pretty much plug in each of the output with the original matrix, the new output with the original matrix values. So time and complexity is m by n, because we do a for loop with the m by n to the space time complexity, and it's also a space complexity of n by n as well, or r by c, I should say, because we are formulating a new well, r by c and n by n are equal, so the new space complexity is m by n as well. And that's pretty much it. Have a great day.